Welcome everyone. Let's learn how to differentiate logarithmic functions. F of x is log base a of x, f of x is ln x. I will give the derivatives first. 1 over x log base a of e, and for ln x, 1 over x. Some people don't need to understand the logic behind of this. We cannot force anyone to understand why. So for those people, these are the derivatives. You can formalize it like this, you can memorize it like this, and use it in problems. Most of the time, we will be working with ln x, but derivative of log is also quite important. Let's start for those who want to learn more. We will use the limit definition we have. What was it? Limit of f of x plus h minus f of x over h as h approaches to 0. And we will use two log properties. Log a minus log b can be written as log a over b. R multiplied with log a, we can write this as log a, and I send my r as power. These two properties from high school, from pre-algebra, pre-calculus, I don't know, we need to know, and we will use these two properties now. Let's start using the limit definition. H approaches to 0. F of x plus h, we have log base a of x. So log base a of x plus h minus log base a of x over h. I want to keep the 1 over h out. So 1 over h multiplied with log. Now I want to use my first property. A minus b is equal to a over b. The bases are the same. X plus h over x. 1 plus h over x. Why did I separate 1 over h? Because now I'm going to use my second property. H approach to 0, log base a, I forgot the a here, 1 plus h over x, and to the power of 1 over h. The reason I did this is I have a special limit. Do you remember? X approach to 0, 1 plus x over 1 over x to the power of 1 over x. This limit is e. This was a special limit for us. If I can transform this inside this part to this, then I will get the limit. I will say this is equal to e. Right now, I don't have it exactly, but I want to transform it somehow. To do that, I will start with let h over x be u. I have h over x. I need to figure out what 1 over h is. So from here, x over h is equal to 1 over u. 1 over h is equal to 1 over u multiplied with x. Limit h approach to 0, log, or base is a, base a of 1 plus u to the power of 1 over u times x. Instead of 1 over u plus u multiplied with x, I want to write h over x for u, 1 over u multiplied x. This is equal to, I will write h over x for u, so x over h multiplied with x, which is also equal to x over h multiplied with 1 over x. Limit h approach to 0, log base a of 1 plus, I'm going back to h over x. Instead of 1 over u times x, we will use this now, this equation we found. We can write this as x over h to the power of 1 over x, because power of power, what do? We multiply the powers, which is the same thing here because these are multiplied. We did not change anything with this. H approach to 0. The important part is if I write this back, h approach to 0, log base a, 1 plus h over x is u, x over h, 1 over u, and this is to the power of 1 over x. Instead of h approach to 0, we can write u approach to 0. Why? Because if h approach to 0, u can approach to 0 from, where is it? Where's 1 over h? From this equation. So we don't change anything. Instead of h approach to 0, I will let my u approach to 0. I can see from here I got the famous limit that I know before, which is equal to e. And there's no other u in this limit. Limit of log base a of e to the power of 1 over x as u approach to 0. There's no u here, so all of this is a constant. Log base a of e to the 1 over x. By the logarithmic rules, 1 over x multiplied with log base a of e. We found the derivative we gave before proving this. For ln x, we have to be smart. Fx is log base a of x. F derivative of this is we just differentiate it. 1 over x log base a of e. If I let a be e, I will get ln because log base e is ln. From here, fx will be log base e of x ln x. F derivative x will be 1 over x will not change. Here's my e, log base e of e is equal to 1, so f derivative x will be 1 over x for ln x. In other words, if we have ln x and we want to differentiate this, we will differentiate inside of it first, and then we will divide it to the inside of it. Let's see two examples. First example, fx is equal to ln sine x. We want to differentiate this. Differentiate inside of it first. Derivative of sine x is cosine x. This is over inside of it sine x, which is equal to cotangent x, cot x. Log base 3 of x squared minus 1. Be careful, this is a composite function. First, we will differentiate the log by the formula we just figured out. What will we do? 1 over x. Let's write the formula again. If you want to differentiate this, 1 over x multiplied with log base a of e. Our x here is x squared minus 1. 1 over x squared minus 1 multiplied with log, my a does not change, 3 log base 3 of e. Did I differentiate it? No, I differentiate the log. Now I need to differentiate inside of this. Don't forget, derivative of x is 1, so there's a 1 here too technically. But multiplying with 1 does not change anything. If I multiply with the derivative of inside of this log, it changed though. So 2x derivative is 2x over x squared minus 1 multiplied with log base 3 of e. We want to differentiate fx ln x plus root a squared plus x squared. I don't know if I gave this before, but let's say we want to differentiate root fx. The faster you can, of course, use the power rule. You can write the root as 1 over 2, then differentiate according to that. But derivative of under root fx is 1 over 2 root fx multiplied with f derivative x. I use this because it makes things faster. All right, derivative of ln, we will differentiate inside of it, then we will divide inside of it to the derivative of it. Derivative of inside is 1 plus, now I will use this formula for root a squared plus x squared. Again, you can use the power rule, doesn't matter. I will use this method. Since you learned every method, you can do whatever you want. 2 root a squared plus x squared multiplied with derivative of inside. A is a constant here. Constant. Differentiate a squared is 0. Derivative of x squared is 2x. Cancel the 2's out. So derivative of inside is 1 plus x over root a squared plus x squared. I want to make things easier for me. I will write this as a squared plus x squared under the root, of course, plus x over root a squared plus x squared. Now I need to divide this with inside of ln. Divide it with x plus root a squared plus x squared. These can cancel out because you can write this to here and as multiplication of these two terms. Cancel these out. The answer is 1 over root a squared plus x squared.